Hi folks, it's Joseph D here again. Another video on some metal casting. Here I'm casting a gearbox, which is an offline gearbox. That's my pattern in the flask, ready to be for sand to be sieved over and then cast. I put my white parting powder down, or you can use talcum powder, just to help the pattern come out of the sand more easily and make sure the sand doesn't stick to the work surface. That's my sand under here. I've got a load of sand, big container full, ready to go. I'll pack this mould together and then I'll come back in a minute and show you what it's like once I remove the pattern. Back again folks. Okay, bottom half of the mould is rammed up, which is going to end up being the top half because this mould is going to be flipped over once I've rammed the top part. So the top part becomes the bottom and this part becomes the top, because we're going to pour the casting that way through. So that's it so far. Get our cope and put it on. Then we're ready to ram up the other side of the mould. Parting dust again. This is to ensure that both halves of the mould don't stick together. Right, cope goes on. Now we're ready to fill the other half of the mould. Just to show you, before I fill the top half of the mould, this is our core maker. This gearbox at the moment hasn't got a hollow, and this pattern for this gearbox hasn't got a hollow. Now with this area here, we need it to be hollow for where the gears are going to go. So we take a couple of pieces of wood like this, which they're screwed together. We lay it flat on a flat surface, ram it up with sand, then unscrew the two screws and carefully remove the core. And we place this core, when this mould is turned upside down and this piece, which has got no cavities in it, is placed facing upwards, we place this core we've made here in the centre. Now the whole thing is flipped over and we cast it from this way up. What's going to happen is the aluminium's going to flow around the core we've just put in, and it's going to take the shape, and it's going to leave a void in this casting when I remove the casting out of the mould when it's finished. We'll show you this later on in detail as it happens. Just so you can see how the mould is rammed up, we put our sand in loosely, then we ram it all the way around first. Then ram the centre. So our sand is all tightly packed. We keep doing this in stages, so that way we get it packed densely. Same again. This is just a quick job for demonstration purposes, but this is what happens. Once we fill this to the top, we go across with a longer piece of wood like this. Mould and core are being rammed. That's the mould rammed. That's the core rammed. Hi folks, as you can see, the mould is apart and I've taken apart the core former as well. That's our core, being nicely formed. That's the other half of the core former. When these two pieces come together, they make that shape, which will leave the cavity inside this casting here, which when this pattern is removed, this mould is turned upside down, which is where I'm going to pour through. And this mould here over here is the right way up. This is the correct way it is now. Now you can see very faintly, there's, excuse my camera cord, there's an outline that's going all the way around here faintly of the shape of the gearbox, which is that shape. Now this is my guide to tell me where about to place the core. So I have to place the core as central as possible so that it, you know, forms the cavity in the center of the casting. So I'll place this core in place now, and I'll come back to you once it's in place. This is the core again. This is what we're going to be using. Here's the next stage. We've put the core in place, which is here. That's the thing that's going to form the shape of the cavity that's inside this gearbox. And you can see there the outline of the gearbox going round. This is being placed as centrally as possible. Okay, that's that one. Now I've removed the pattern. The pattern came out cleanly with not much casualties. Tiny little bit of chipping around the edge at the very top, which is very faint, that doesn't show. So any little bits that come here like flashing will be ground away, which is no problem. That's the inside. Get a good look at that. Now in this cavity down here in this hole, this is where I'm going to use my sprue cutter. And what to do is to cut a hole like so. This is going to be where the metal's going to enter the mould, because this piece is going to be flipped over. Yeah, I've got my hole where I'm going to pour my metal in. So all there's left to do now is to just give the mould a good blow with the air compressor, and then put this on top of here. Put this mould on top of this one. And then I've got another piece which is over here, which is, I've already rammed this one up. This is my extended runner or riser. This is designed to give it more pressure to go in the casting, to give it better finish. My friend, my foot boy, does this, and he always uses extended feed or runner. So I'm doing the same thing today to try it, to see what it's like. Like I say, the more higher the runner is, the more pressure goes into the casting, and hopefully it should be a good job. This remains to be seen, but I'm going to try it. So I'll be back in a minute once I'm ready. Once the mould is all assembled and I'm ready to start pouring it. Just one last look at the mould before I put it together. That's the way the metal's going to come through that hole there, and it's going to fill this cavity in here. And this sand core is going to leave the hollow in the inside of the casting, which is the gearbox housing. So this area here is where the gears are all going to go, into this hexagon piece. So I'll place them all together, melt the aluminium down, and away I go. Let that melt for a bit. As you can see, it drops down to again 579 because I've had the furnace open, and I've just added some freezing cold metal in there, so that takes the temperature down too until it builds up again. Once that metal that I've just added reaches the same temperature as inside the crucible, then the temperature will shoot up again. Be back in a minute. Right, all mould is all set up and ready to go. There's the extended runner, just like my friend my foot boy does. This works out good because it gives the casting more pressure, which gives it a better finish. That's my theory anyway. David, correct me if I'm wrong. Right, so the mould is together. I've taken a precaution. I've put 2 screws there and there to keep the flasks together, because the last thing I want to do is, with increased pressure, I don't want the flask to open up, as I've had this in the past. So a couple of screws either side, or you can use some C-clamps or bricks or whatever you got, just to keep them together, because the more pressure coming in gives it more tendency for these two to separate them for a little bit of flashing or metal to bore out. As I just placed the tray under here, which is, you know, my insurance policy. Should we have any leaking metal or anything, this tray will catch anything nasty before it goes anywhere else. So that's there to contain anything. Ready to do the pour. Once I reach 660, I'll stop the furnace and add the flux and the degasser. At the moment, I'm just playing the waiting game. Here's the big moment we've been waiting for. I'm just about to do the pour now. Aluminium is being degassed, fluxed and skimmed. All the dross have been removed. So here I go. Pick up my tongs and I'll pick the crucible up. Here we go. Perfect. Whatever's left will go in an ingot. Let that cool and then we'll open the mould in a minute. Hi folks, we've left this for 15 minutes to cool down. This is the exciting part of the video, is to open up the mould and see what we got today. So here we go. I get my pliers, start to pull it apart. This reminds me of what my foot boy does. It's good influence him. Right. That's that out of the way. The thing is to carefully open the mould. Now this is going to be mad hot and there's going to be lots of smoke. That's the core. Voila! Let's get rid of this. Remove that. Now if I grip that with the pliers, I should be able to clean it up with a screwdriver or something. You can see that. If I chip away with a screwdriver, this will all clean up. Slight bit of flashing here in the corners, which was mentioned earlier in the video, but that's nothing serious, nothing that won't grind away. This is our core in the middle here. We just break that up, we should have a nice cavity in here. This is where our gears are going to go. Tip that away. Very nice. This must be my foot boy's influence because I'm getting very good at this now. When I started I was rubbish. He's a good friend, him. There we are. Not bad at all. Just a little bit more cleaning to do. We grind these away and what's this name? How should we say? We file these down on the belt linisher all the way round and it should be alright. We cut this long stump off now because we don't need that. We only need it up to where that piece is that's sticking out with the pattern on it. The piece that has the pattern going across like this, that piece we're keeping. So we're going to cut it there with the hacksaw. And then this can go on the lathe to be machined. This is an offline gearbox. The one we made previously was an inline gearbox, which is yet to be assembled, and a video of that one running will be shown, as well as this one when it's finished. Hope you like this, guys. Thanks for checking out my videos. If you want to check out my other videos, I show various videos, including one of my castings being machined as well. I don't always do it on the same video here because memory stick space is an issue. So thanks again for checking this out. Take care whatever you do and be careful, this is very dangerous work. Cheers, bye. Two machines I use to deal with new castings are these two. Proxon bandsaw and Clark belt in disc sander. Now, this is the one we use for cutting off the stump. Voila. That gets rid of that and we're left with this. That gets neatened up on the lathe later on. Now this one is the belt in this sander. This is the one that's used for removing any imperfections around the casting, including any flashings like we get here. So I haven't got enough memory stick to video this in action. So what I'll do is I'll sand this up and I'll come back and show you once I've finished, so you can see what it's like. But you get the idea, just sand things down. So guys, here's the casting that's been partly machined on the sander and it's been trimmed with a bandsaw. So it's not too bad, it'll do the job. Inside is very nice, that hasn't been machined, but the sides have slight issue of air bubbles in places, but nothing too serious. My degassing tablets didn't work very well this time for some reason. Maybe I didn't use enough of EcoGas 16. Well, still it's a good gearbox anyway. A few potholes, nothing serious. Better luck next time. Next will be to machine this on the lathe and bore it through and everything for the shaft to go through. Machine the recess for the bearings to seat. Make a motor mount plate, which is just a piece of aluminium about 10mm thick or 8mm thick, and it's shaped to the same shape as this. It's got 4 holes screwed, sorry, 4 holes drilled through it, which are tapped for the screws to come through from the front to fasten this onto it. There'll be 2 pegs either side, which act like dowels to locating pegs to locate this onto the motor mount plate. The idea of using a motor mount plate is you can use any type of gears inside here, which is different sizes, which vary, so therefore the motor can be mounted in different positions without having to do one casting that only allows the motor to sit in one place only. So with the beauty of this, you can just move the motor any location you want on here to accompany the gears that are going to go in here, which is depending on their size. So that's the next job. Once I make the motor mount plate, I'll screw the whole thing together and lap it round on here, so that way it's all identical, it's all the same. That makes a gearbox, just like my gearbox on the other video which I've done last week with the inline gearbox. Check out my other YouTube video to see that one. Well, this hasn't turned out too bad. A little bit disappointed with the air bubbles, like I said, but that can't be helped, you know. These things happen. I know better next time to use more EcoGas 16 and get a decent plunger to be able to plunge it right down to the bottom of the melt. That's where I went wrong. Thanks for watching. Take care. Bye. This is just for those who want to know how I do some of my machining on these castings. Here's the casting set up in the lathe now. I've been machining the centre boss, which is to be 30mm. See, it revolves like this. It's all balanced. It's hooked onto a long shaft that goes through into my chuck. And this shaft is being pressed into this with a 10-ton press. The hole in the centre is a 10mm hole. The shaft is being spleened so that it grips, it doesn't move. Now, this centre hole, like I said, is about 10mm. The overall size of the boss is 30mm, same as the Unimat. And this will be designed to be mounted to the Unimat with it'll have a shaft which is the same diameter as the Unimat shaft, which is designed to accept the Unimat SL lathe bearing, sorry, not bearing, pulley. Now, that's the front of the original motor. You see the centre boss is there. Shaft size is about 6mm or 5.8 to be precise. This is a Unimat motor which I've taken apart and built myself. I've changed the insides. This motor's very loud, so be warned. I'll just put my camera down a minute and I'll run it and show you it working. But this is too loud for my lathe and I don't really want this. So that's why I'm after making something a bit more quieter. What a racket. I'm after something more quieter with a lot of torque. This motor was fan cooled. I put a fan inside it and I drilled the holes, you know, so it can get more air, so it runs cool. But it's just too loud. I mean, it sounds like a router. So this is not ideal. So I thought what we'll do is we'll copy this area here onto a new casting, which is designed to hold a sewing machine motor. Couple of gears in there. Shaft, which is the same as this, which will drive the Unimat pulley, which will drive the Unimat belt system, and we'll be able to have a sewing machine motor mounted onto here via motor mount plate. So this should be good once I've finished. I've got the space in there for my holes, which are going to be to secure this onto the lathe mounting plate, which is this casting here that gets secured to the lathe motor mount plate. So I just use all the measurements off the Unimat motor and voila, we'll have something really good. Well, this is my project so far. The other casting was the inline gearbox. It's also designed to do the same job as this, but that one is a little more tricky to put together. So this only requires 2 gears, so this works out better with less hassle. Thanks for watching. We clamp this on the milling table and we centre it up using a drill piece or a piece of bar like this chucked up in the milling machine. We bring the milling machine down until this lines up central. Then we clamp the table so it's in that position. Swap this over for the boring head. Put the boring bar in. Adjust it gradually to bore out the size of the bearings which are going to go. And then we do the same thing again on this side. We level it up, clamp it on the table and bore it through the same way to accompany the bearings. So this is this casting so far. These air bubbles are just unfortunate, but we'll fill them in with epoxy resin, sand it down, and paint it. You would never know. Well, it's not a bad attempt anyway. I'm happy. Next casting will be better. More Eco Gas 16. Bye.